Suppose a family has 150,000 30-year mortgage at 6.1% compounded monthly, and we want to find the monthly payment, and then we'll also find the unpaid balance after 10 years and 20 years. All right, so let's take a look at the monthly payments. We're going to be using this formula, which will amortize the loan. So if you're not familiar with this formula, let me redefine these variables for you. So R is going to be our monthly payment, and P will be the principal amount, or in this case, it will be the loan amount. And the little r is going to be the interest rate. And N is the number of times we're going to compound, so number of compound. We can say a compounding period. And T is, of course, is going to be time in years. All right, so now that we have defined our variables, let's sub in what we have given to find monthly payment R. So we see that we have a loan amount for this much. So our P is going to be 150,000 for 30 years. So T is going to be 30 years. And at a rate of, so we're taking 30 years mortgage for 6.1% rate. So if you convert that to a decimal, that's 0.061. And since we're going to be compounding every month, our N is going to be 12. All right, so with this information, now we can figure out what R is. So R is going to be our monthly payment, which is 150,000 times the rate, that's 0.061, divided by N, that's 12, all over 1 minus 1 plus the rate, that's 0.061, divided by 12 to the power negative 12 times 30. So this will give you the monthly payment. Now, if you put this in your calculator carefully, you'll get that R happens to be $908.99. So this is the monthly payment. So that answers the first part. Now we can take a look at the second part. Well, actually the first part of this problem, which is what is the unpaid balance after 10 years? What that really means is we want to know what will be the loan amount for the remaining 20 years. So if you take off 10 years from 30 years, you'll have 20 years. So we want to know what is the unpaid balance. So balance for the remaining 20 years on this loan. So that means unpaid balance after 10 years. So we're going to be using our time to be 20, assuming the same interest rate. So we have R 0.061, and we're still compounding every month. And now we're looking for what is the loan amount. So you can say the principal amount, or the loan to be paid off for the remaining 20 years. So this is how we're going to set it up. Now, if you, again, take this formula and just solve for P, you will be able to find what P is equal to. So I'm going to show you that right here. I'm going to go ahead and try to solve for P because we want to know the present value of this loan. That will be the unpaid balance. So we'll multiply both sides by the denominator right here. So treat all of that as a single term. So you'll have your P is equal to R times 1 minus 1 plus little r over n to the power negative nt divided by r over n. So that's the formula for the present value of this mortgage. Now let's go ahead and plug in what we have given, and that will give us the loan amount, the remaining unpaid balance. So this is equal to R. Well, we know that it's going to be $908.99 times 1 minus 1 plus the rate, that's 0.061, divided by 12 to the power negative 12 times. So T, we're using 20 for the remaining 20 years on this loan. divided by 0.061 divided by 12. And then if you plug this in your calculator carefully, you'll see that you'll have about $125,765 left on this loan after 10 years. Now let's go ahead and add a little bit more to this problem so we understand this a little bit better. So we are starting with a monthly payment of $908.99. So for 10 years, you're paying, so for 10 years, you're going to be paying $908.99 for 10 years. Well, there's 12 payment of that. And this will give you about, if you put this in your calculator, $109,078.08. So this is how much you're paying for the first 10 years. And we just found that after 10 years, the remaining balance is this much from the initial loan. So our loan amount happens to be $150,000. So after 10 years, we know the balance came out to be $125,765. And you paid this much for 10 years. So if you subtract these two numbers, you'll have about 24,235. So this is how much you paid for 10 years. So what that really means is the rest of this amount went on interest. So for 10 years, your interest that you paid would be $109,078.08 minus how much went on principal amount. And this gives you how much was on interest. So about $84,843.08. This is how much is paid on interest. So also hopefully this gives you a little insight of what's going on with these numbers. Now let's finish up the next part. So the next part, we want to know what is the amount or the unpaid balance after 20 years. So that means you still have 10 years more to pay. So we want to know what will be the balance for the remaining 10 years. So after 20 years, our unpaid balance will be, so we're looking for the principal amount when t is equal to 10. So that would be the remaining time on the loan. So we'll have the same setup. So we'll have P times, P is equal to R, which is 908.99 times 1 minus 1 plus the rate, which is 0.061 divided by 12 to the power of negative 10 times 12 all over 0.061 divided by 12. So this will be the balance on the loan after 20 years. So this is equal to about 81,432.6. So this is the unpaid balance after 20 years. All right, so I hope this makes sense.